Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on August 5th, 2025, just 3 days ago. The big idea is a general framework that brings reinforcement learning to any agent with near-zero code changes, decoupling training from agent execution while still handling multi-turn reasoning, tool calls, and complex workflows. The paper is titled Agent Lightning: Train Any AI Agents with Reinforcement Learning. And the implications for model training are quite significant. In short, the framework model's agent runs as a Markov decision process, uses hierarchical credit assignment, and shows steady reward gains across text-to-SQL, retrieval augmented generation, and math tool use. Building on that, posts highlight zero-code agent optimization across LangChain and other stacks, decoupled training via Lightning server and client, and broad compatibility. Engagement looks moderate, with one post around 76 likes. Alright, here's the overview graphic. On the left, user-built agents run and generate traces. Those are the training trajectories. In the center, the agent Lightning box orchestrates credit assignment and converts those traces into transitions. On the right, a reinforcement learning engine updates the policy. The loop closes by sending updated models back to the agents, enabling continuous improvement without changing agent code. Next, the figure walks through a retrieval augmented generation run as evolving states. On the left, semantic variables like user input, query, passages, and answer flip from gray to green as components fire. The brackets show which component updates which variable. Moving right, the dashed box logs each call with its input, output, and reward. Then data extraction filters only policy calls for reinforcement learning transitions. Building on that, the figure contrasts three training styles. On the left, single call GRPO groups multiple full responses to one task, then scores them. Below it, prior multi-turn GRPO groups whole trajectories and masks tool tokens. On the right, LightningRL breaks each run into transitions, applies credit assignment per action, then uses standard single-turn reinforcement learning on those pieces. Now we zoom into the Training-Agent Disaggregation diagram. On the left, the reinforcement learning framework hosts the trainer and the large language model engine on GPU servers. On the right, any agent stack, like AutoGen or LangChain, runs independently. The green arrows show the loop. Agents send rewarded traces to the server, then receive an updated model through an OpenAI like API. Moving to the table, we get a compact snapshot of the three evaluation tracks. Text-to-SQL uses LangChain on the Spider dataset, with an SQL executor, 3 agents, and 2 of them tuned. Open domain question answering runs on OpenAI Agents SDK with MuSQL and a Wikipedia retriever, 1 agent tuned. Math question answering uses AutoGen with CalcX and a calculator, also 1 agent tuned. Wrapping up, 2 big takeaways. First, modeling agent runs as a Markov decision process, plus hierarchical credit assignment lets reinforcement learning tune multi-step tool using agents without code changes. Second, the disaggregated server and client design enables continuous, observable training in real deployments. Markov decision process means states, actions, rewards, describing decision-making over time. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.